Good morning, everyone. Welcome back to my channel, Study Plan. Today, we are going to continue with the chapter Motion and Measurement of Distances. But today, we are going to cover the advanced level. I have covered all the basic methods in the last two parts of my video. So, let's start with the advanced level today. The first topic which we are going to study on the advanced level is going to be the scalar and the vector quantities. These are very important and very easy too. Scalar quantities have only magnitude and vector quantities have magnitude with direction. Direction can be north and magnitude can be 5 meter, 5 kilometer, etc. Okay, and magnitude again it could be 5 gigameter, let's say it could be meter, whatever. Okay, now I'll give you an example which is the introduction for our first scalar and vector quantities. Okay, so this is north, this is south, this is east, and this is west. Okay, so if I'm standing on this point, okay, this point is point A. Okay, I want to go to point B. Okay, I want to go to point B. This is point B, right? Now first if I travel 5 kilometer north, okay, then I come back from that point and come back to 5 kilometers south and reach back to point A. Then I go to point B, traveling 5 kilometer east. Now can you tell me how much distance I traveled? So 5 plus 5 plus 5, which is 5 into 3 equals to 15. So basically I traveled 5 kilometer. But what if I just traveled from point A to point B? A straight path, only 5 kilometer towards the east without going towards the north and then coming back to point A. That would be 5 kilometers only. So, as you all can see here, that there's one short path and one long path, and that long path can be anyways. Like I was going from to point B from point A in a straight path, maybe this way I go in a curved path which is known as the curvilinear motion. Okay, now I'll explain you about distance versus displacement. Distance is a total length of path covered by a body. So the 15 kilometer I explained you in the last slide was our distance and displacement was 5 kilometer because it is the shortest path between the initial and final position. Now I'll give you one more example. You can see this is the distance and this straight path is known as the displacement and distance. So are you getting the difference between both the terms? Okay. Now the SI unit of distance is meter and it is a scalar quantity since it has a magnitude. But if we talk about displacement, we say that the SI unit is meter, but it is a vector quantity since it has the shortest path, which is in only one direction. The shortest path can be only one. Okay. So it has the magnitude also as 5 kilometer, and it has this direction also. Okay. Now here's a numerical for you all that Rohan wants to go from A to C. He takes the path as shown in the figure. So see, he goes from this here and then travels to point C. Okay? Right. So his distance would be 4 plus 3. which is equal to 7 meter. Then if he takes this path, he would only travel 5 meter, only one straight path. So as you can see that on one side he is traveling a 7 meter and on the other side he is traveling only 5 meter. Okay, so which part should he take? He should take this 5 meter path. So as you can see in the solution, I have shown you the distance and the displacement both. Now calculate the distance and displacement when a ball jogs around a circular track of radius 7 cm. So this is our circular path. Okay. Now in this circular path, our radius is 7 centimeter. Okay. So now as you can see the circular path, this boy is jogging around the circular path. So we need to calculate the distance and the displacement when a boy jogs around the circular path. Track of radius 7 centimeters. So this is 7 centimeter. Okay. Now the area, the circumference, the formula of the circumference is 2 pi r. Okay, so pi's value is 22 upon 7 or 3.14. Okay, I hope you all are getting this. Now, and the r is the radius. So 2 into 22 upon 7 into 7. So we can cancel 7 and 7, we get 1. We can cut this 1 because we are multiplying 2 into 22. We get 44. Hence, this circumference of this circle is equal to 44 centimeters. I hope you all are getting it. And the displacement is when the initial and final position is the same, then the displacement would be 0, as you can see in the solution. Okay. Now comes speed. It is defined as the distance traveled by a body per unit time. Speed is measured by an instrument called speedometer. Speed equals to distance upon time. Its SI unit is meter per second or m upon s. Other commonly used unit of speed is kilometer per hour, and speed is a scalar quantity. Now conversion of kilometer per hour to meter per second. As you can see in this, 1 kilometer upon 1 hour is equal to 1000 meter upon 60 into 60 seconds, which is 3600 seconds are there in 1 hour and 1000 meter is there in 1 kilometer. So 10 meter upon 36 seconds is equal to 5 upon 18, right? When we cut it by 2. Hence multiply the speed with 5 upon 18. So 54 kilometer per hour is equal to 54 into 5 upon 18. 18 will be cancelled by 54 by 3 times. So 3 5s are 15. 15 meter per second is our answer. Now conversion of meter per second to kilometer per hour. So as you can see, 1 meter is equal to 1 upon 1000 kilometer and 1 second is 1 upon 3600 seconds. So it would be the reciprocal. So I hope you know about the reciprocal. So it would be multiplied by 3600 upon 1. Now multiplication is easy, so you get 3600 upon 1000, which is equal to, when we cancel two zeros, we get 36 upon 10, and when we cancel it by 2, we get 18 upon 5. Hence multiply the speed with 5 upon 18. Example, 54 km per hour is equal to 54 into 5 upon 18. It would be wrong. Okay. So you will not generally get these kind of questions like multiplying 54. So basically you could get as 45. Okay. Or maybe it's 10. So you would get 180 km per hour. I hope you are understanding it. So thank you everyone and have a nice day. Please like, share and subscribe my channel, and please ring the bell too, so that whenever my video is uploaded you get a notification. Thank you. Have a nice day.